I will try one more time to record. This is my third time trying to record this PowerPoint. I don't understand why it's not working. Was to discuss the mechanism of the AZT. You've got the PowerPoint, I guess, so I'm just going to review what I stated. The AZT treatment in the HIV disease or virus. First of all, I was going to briefly review the HIV life cycle steps. There's entry, which is binding of this goes along with the PowerPoint. Entry is binding of the HIV to receptors on the CD4 cell. There's reverse transcriptase, which the virus uses to convert its RNA into DNA. There's integration, where the virus uses the enzyme integrase to insert its viral DNA into the DNA of the host CD4 cell. There's replication, which is where the HIV replicates in the activated cells, and a proviral DNA is formed by transcription. There's assembly, which is the new viral proteins and enzymes move to the outer membrane and assemble. And then there's budding and maturation, where the virus bud is released from the host CD4 cell. So there's a few different drug classifications for treating HIV, and the one that we're going to focus on in this presentation is the AZT, which is a thymidine analog. Excuse me, I'm very, very tired. I have worked, let's see, it's midnight. I have sat at this desk without moving except to go to the bathroom twice since 8 a.m. And I've fielded multiple calls to try to set up services for my 92-year-old mother because I've got no one else to help me. It just sucks. Okay, so by the time you're into probably the 7th or 8th PowerPoint slide, I have a couple pictures of like different polypeptides, and the far left one is the let's see what it is. Let's see, AZT is a thymidine analog, which thymidine is on the far left, and in the middle is the AZT drug. And they look very, very similar, is what I wanted you to see. AZT is a thymidine analog, which works as a nucleoside reverse transcriptase inhibitor. It undergoes intracellular phosphorylation by host enzymes, when the negative phosphates, of course, are added to the protein, and the kinase transfers them to the target, changing the 3D protein structure and function. Reverse transcriptase would normally use the nucleotide analogs A, T, C, and G to build DNA strands, but AZT inhibits this as a competitive inhibitor. DNA elongation is thus terminated after the AZT triphosphate is incorporated. My other two videos were twice as long as this, better explanation, better visuals, but I can't do this anymore. I've had it. Thank you.